Hello, my name is Andrei, and today I will tell you about OSA, a multi-agentic tool for end-to-end repository improvement. OSA can create README, documentation, CI/CD scripts, and many other things for any repository. So, how does OSA work? The pipeline is quite simple. A user provides a link to the repository, any additional context that can help to create a README file, for example, scientific article, if the repo is based on it, and the user's query, what to do with the repository. Then, OSA processes the repository, creating inline doc strings for classes and methods, and wrapping them into a usable documentation page, generating a README file, CI/CD scripts, community docs, for example, pull request template, license file if missing, PDF report with recommendations for repository improvement, and even about section and topics if the repository is hosted on GitHub. Finally, OSA adds all these changes into a pull request, and the only thing the user should do is to review it and merge it. So, who needs OSA? Of course, researchers from any scientific domain. Nowadays, not only machine learning researchers publish their code in addition to paper, but also biologists, chemists, and physicists. And they usually don't have good developer skills, so their repositories lack the components important for reproducibility. Professional developers also can use OSA for a fast generation of project documentation and CI/CD scripts, because many of them often postpone creating it manually. Another category of users is MLOps. They can have dozens of repos in storage, and all these repos should have up-to-date and clear documentation. Implementation of OSA into the repo processing pipeline can solve this task. How does OSA works technically? First of all, the chat agent receives information from the user. Then the analyzer extracts data from the provided repository and transfers it to the planner agent. The planner agent creates a list of operations and sends it to the executor. The results of execution are transferred to the review agent to check if all of them were done correctly and without errors. If there is any additional request from the user, the reviewer also processes it. After all, the finalizer agent aggregates all information and artifacts and combines them into a pull request. OSA has two working interfaces. You can try command line interface to use the chat agent, or you can use a web interface for more user-friendly appearance. Thank you for your attention. Now I will demonstrate OSA's capabilities using the web interface. Here you can see the interface of web version of OSA, and we will process the repository called DMAG, which is based on the paper about magnetic nanoparticles. So as you can see, the README here is not big enough. There is no license in this repository, and if to look on Python scripts, they are not organized into classes or methods and look more like Jupyter notebooks, I guess. So what should we do? We paste the link to the repository. We also choose the scientific paper and upload it. And so let's configure it. Yeah, we will generate README. We will not generate any doc strings because the code isn't organized into classes or methods. We will generate PDF report about section, community files, license. Let's check MIT, for example, and translate README to Russian language too, not only English. So let's start. As you can see, OSA finished its work. So let's look at the pull request. OSA generated description for the repository. It extracted the home page from the paper, generated some topics, and a report with recommendations for repository improvement. So what's in this pull request? Community documents, for example, contributing template, some CI/CD scripts for unit testing, for example, for linters, license file, MIT README, which has broadened README in Russian, requirements file, which is updated, and a PDF report